Talk about the origins of petroleum, but first I wanted to talk about the origins of the word itself. Rock outcrops at the surface of the earth have been producing oil for centuries, and this oil was known as rock oil because it appeared to be coming out of the rock or seeping out of the rock. But then about the middle of the 19th century, somebody coined a word petroleum, and what it was is a petra meaning rock. It was a Greek word for rock. And oleum was a Latin word for oil, and they combined these two words to call it petroleum. And it became a popular word, and they eventually adopted by the industry itself, and now it's known as the petroleum industry.
In our search for oil, it is necessary to understand the theories of how crude oil is made. To begin, we will talk about its origins, where it comes from. Next, we'll look at its chemistry and with discussion of reservoir rock properties. First, its origin. Where does oil or petroleum come from? There are two theories about where petroleum came from. The first, the organic theory, states that oil was developed over millions of years from organic material, from the remains of animals and plants that were once alive. The protein life floated in the sea like plankton and algae, then died and fell to the bottom of the oceans. Their remains became the source for our oil and gas. The second theory is called inorganic. In this theory, the source of our oil is from chemical reactions between minerals. In the laboratory, scientists have been able to make methane gas by applying heat and high pressure to minerals. Even though a very small percentage of oil today may have developed from inorganic chemical reactions between minerals, the source of most of our oil appears to be the result of organic decomposition. This decomposition is the decay of the remains of animals and plants that died millions of years ago. Some people think that maybe oil was formed from all the dinosaurs that used to rule the earth millions of years ago, but that is also untrue. There just were not enough dinosaurs to count for all the oil. When I talk about animals, I'm talking about the tiny, microscopic animals that lived in the sea. Animals like plankton and algae that lived and died in the shallow seas and oceans around the world. Now, they died under special circumstances, and what do I mean by that? As you know, when most animals die, other animals and bacteria arrive to consume their remains, leaving nothing. In the shallow waters where these animals lived, swift currents came along and pushed these animals down to where there was not enough oxygen to live, and so they died. These animals went from an aerobic environment, where there was plenty of oxygen, to an anaerobic environment with little oxygen, where they all died at the same time. In anaerobic environments, there is also not enough oxygen for most animals, microbes, or bacteria to come along and eat the remains of the plankton and algae, so they just lie there until they get buried by particles of silt and sand. This cycle gets repeated over and over again. A typical example of where this occurs is the Bosphorus Straits at the Black Sea on the coast near Turkey. These straits are a shallow, narrow channel that widen out into the deep sea. The currents force the water coming out of the straits down, carrying the microscopic animals with it. Now, over a period of millions of years, these layers of remains and sand and silt particles are buried and are covered by more layers until the first layers get buried very deep. All the weight of these layers start to press down and are squeezed, causing increases in pressure and temperature until the sedimentary layers are formed into shale. Sediments changed into rock, and the little dead microbes get cooked into hydrocarbons. This is the theory of how petroleum and coal are made. Oil is formed from animals like plankton, coal is formed from vegetation like plants and trees, and gas is formed in deeper formations where the microbes are cooked longer.
In this section, we're going to look at some of the basic chemistry of petroleum. We're going to look at the molecular structure of various types of petroleum. This is necessary for the petroleum engineer to understand some molecular structure to have a better understanding and how to extract the oil from the earth.
Hydrocarbon molecules are found in all living plants and animals. These molecules are made up of hydrogen and carbon atoms in many configurations. We refer to the atoms as C and H. C for carbon and H for hydrogen. This means that a carbon atom can attach itself up to 4 atoms of hydrogen. A common combination is 1 carbon and 4 hydrogen, which we call methane. It is the simplest of the hydrocarbons, but there are many other combinations of carbon and hydrogen. Methane is a simple 1 carbon with 4 hydrogen atoms. The 2 carbons plus 6 hydrogens we call ethane, 3 carbons plus 8 hydrogen we call propane, 4 carbons plus 10 hydrogen is butane, etc. These straight-line molecules are called the paraffinitic molecules. Also, the carbons can form ring configurations. A 5-carbon ring molecule is called cyclopentane, and a 6-carbon with 3 double bonds is called benzene. These are used in chemical reactions to make plastics and polymers. Ring molecules are called the aromatic molecules. These molecules are usually trapped within the crude oil and require the refinery process to separate them into other like molecules. We'll talk more about that when we talk about how to refine crude oil. Just know that in crude, there are hundreds of carbon and hydrogen configurations, from the simplest to very complicated, that must be separated out. Another characteristic of oil is its viscosity, which can be measured. Viscosity is defined as a liquid's resistance to flow. In this film clip, there are 2 glasses. One glass contains honey and the other water. When poured out, water pours out into the bowl much faster than the honey. We therefore say that water has a low resistance to flow, or low viscosity, while honey has a higher resistance or higher viscosity. We also measure oil according to its viscosity. Since different oils have a low viscosity or high viscosity, it is important to know the viscosity of your oil. You need to know its viscosity in order to maximize your ability to get it out of the ground or to transport it through pipelines efficiently. The unit of viscosity commonly used in the oil industry is called the centipoise. Let's look at another example. Each of these 5 tubes contains fluids of varying viscosity. Watch the silver balls as they sink to the bottom. The one on the far right sinks rapidly, so we know that that tube contains a fluid with low viscosity. The tube on the far left contains a fluid with high viscosity. Digenesis changes the freshly generated organic material into the crude oil we produce. It is the process over millions and millions of years that changes all those plankton and algae into the oil we drill for today. It is that cooking that I referred to earlier. As time goes by and this organic material gets buried, and over time heat, bacteria, and rock weight or pressure changes this material into oil.